Complex numbers can be transformed from Cartesian form to polar form if we observe the relationship between this triangle that's formed here. Here's our real axis, here's our imaginary. We come out A units, we go up B units in a ordered pair A, B, I. R is once again the ray that was rotated, theta is the angle of rotation. Now I can see from this triangle that the sine of theta is equal to opposite B over hypotenuse R. In other words, R sine theta is B. So if I replace B with R sine theta, I get the y coordinate is R sine theta, but notice there's the imaginary term. I'm going to move that to the front here. As far as A is concerned, and theta, that's the adjacent side, so the cosine of theta is equal to adjacent A over hypotenuse R, or R cosine theta is A. So there's your real part, R cosine theta. So A, BI becomes R cosine theta I times R sine theta. And we're factoring out the R times a quantity, cosine theta plus I sine theta. Now, you can also see here that the tangent of theta is going to be the B value over the A value. You're going to want to check that quadrant, and you can see by the Pythagorean theorem that R squared equals A squared plus B squared. So the following definitions and relationships will allow you to change from one form to the other. Definition: polar form of a complex number. Z equals R cis theta, where cis is short for R times cosine of theta plus I sine theta. If that's the case, R is called the modulus or the magnitude. Z and theta are called the arguments. Z, they're either in degrees or radians. And the absolute value of a complex number is the modulus of that number. So the absolute value of Z is R, the radius. And the relationships between polar and Cartesian, once again, if Z, our complex number, is A plus BI in Cartesian form, it's R cis theta in polar form. And that means A equals R cosine theta, B equals R sine theta, R squared is A squared plus B squared, and the tangent of theta is B over A. Check your quadrant.